Alright, in this video, I want to talk about the basic concept of how of partial differential equations, at least how to solve them. Um, so let's say we have a partial differential equation that looks like ut plus k, not k, equals to k u x x. So in this case, u means temperature. And then t means time, and sorry, x means length, and then k is just an arbitrary constant. It's usually greater than 0. So, what's important here is that in order to solve these differential equations, in most cases, and in MA 303, we are definitely assuming that this function u is a function, a product of two functions. One is x. This is a big X that only contains function of x, and then multiplied by another function of t, and that is a function of only t. So based on this assumption, we can rewrite our original partial differential equation. So rewrite. So ut u of t, that is just so x remains the same, and then t's first derivative equals to k so this is second derivative of x, so that's just going to be x double prime times t. And then you would realize that in order to solve a partial differential equation like this, what we can do is rearrange it. X double prime over x equals to t prime over kt. So whatever the constant in the partial differential equations, in our case, it always follows the t term, not the x term, never the x term. And then what you realize is that these two terms has to equal to n constant in order to have any meaningful solutions. In this case, we're just going to set it to lambda. So, and then we can just take these two things each by one by one. So solve x and solve lambda. So x double prime x equals to lambda. We can rearrange this again. X double prime equals to lambda x, and then x double prime negative lambda x equals to 0. So this becomes a very similar the partial characteristic equation that we just solved before. Similar thing for t. So that will give us t prime equals to k lambda t, t prime equals to negative lambda k lambda t equals to 0. So let's do so this is basic concept, and what you do next is just solve these two ordinary differential equations. So yeah, so we turn our partial differential equations into multiple of ordinary differential equations in the hope that these ordinary differential equations will be easy enough for us to solve and then combine them into meaningful solutions for our original PDE. So let's just do a quick practice, shall we? So let's say let's just say u t t, equals to k kuxx. So very similar. So we're just going to assume that u is a function of two products of functions. One contains x, one contains t. So utt will just become t double prime x, and then equals to k t double prime of x, right? And then you just tweak this expression a little bit. So t double prime, actually let's write x first. X double prime of x equals to t double prime kt. We're just arranging everything, and then we're just gonna set it to an arbitrary constant of lambda. And then so you might have noticed that this it's the same thing as here, what we just did before. So we're just gonna copy and paste, same thing. So save some time. So for t it's a little bit different. So t double prime t equals to lambda. So that will give us t double prime equals to lambda t. Kt. Never mind. K lambda t. So that will give us t double prime minus k lambda t equals to 0. So yeah, this just a little practice for you, and then also tells you the basic concept about why we are doing the things that we do, and then just like the basic procedure and the concept of how to solve differential equations. So let me repeat that. So the reason why we're doing this is just because that we are, first of all, we assume that our solution is a product of two functions. One contains x only, one contains time only, t only, and then we do the separation of variable things in the hopes that we can generate some ordinary differential equations, which are right here, and then we hope that these two will be simple enough for us to generate some parts of the solutions, and then we can combine them into our final solutions for our original partial differential equation. So this is it. This is the explanation of concept and with a little bit of practice, and I'll see you in the next video.